Hi, welcome to a PSL Demo Day. I'm Jason Bacher, Associate Professor of Economics at the University of South Carolina and President of PSL Foundation. Today's conversation is with John Ricco of the Budget Lab at Yale University. John's an experienced tax modeler and part of this new organization launched out of Yale to look at budget policy and propose new ideas and how we might think about scorekeeping. This conversation is an overview of what the Budget Lab is doing with a small preview of some of their modeling infrastructure. But we'll hopefully have John back to share more details on that so we can all get our hands dirty with some of their modeling tools. I hope you enjoy the conversation. All right, well, great. Well, really excited to have John Ricco with us today from the Budget Lab at Yale. John's been doing tax modeling work for, I think, at least 8 years now, and he's now Associate Director of Policy Analysis at the Budget Lab at Yale. And today's going to kind of give us an overview of this new organization, talk about some of their tax modeling tools, and even give us a short demo using them. John, good to have you.
Yeah, thanks so much, Jason. Really glad to be here. My name is John Ricco. I'm the Associate Director of Policy Analysis for the Budget Lab at Yale, a new think tank focused on fiscal policy issues, and microsimulation is going to be a core part of that. So today I want to largely cover some high-level topics, perhaps a little less in the weeds than the typical demo day at this point. But in terms of a roadmap, I want to start by introducing the Budget Lab, give the viewer a sense of who we are, what we're doing, what our goals are, so forth. And then I want to make concrete some of the ideas in terms of seeing how that plays out in our tax microsimulation model. And to even make that more concrete, show an example of how we would configure an example policy reform to run within the model. So in terms of who we are yet another scorekeeping operation in the mix of a somewhat crowded field, perhaps. Where our goal, of course, is going to be to, I would say, broaden the toolkit for fiscal policy analysis to really think in terms of building the broadest yet most practical view of understanding how policies affect both the budget and the distribution of income and perhaps the kinds of economic outcomes that policymakers and the public might be concerned with. Like I said, there's a lot of people already doing this work. Of course, all of the government scorekeepers. We have CBO, JCT, OTA, OMB. We have in the non-governmental side of things, we have like Penn Wharton Budget Model, Tax Foundation. We have CRFB working on related issues, Tax Policy Center, and then of course the more open source, oriented tools of PSL and the policy engine and so forth. And I think it's reasonable to ask what can we add here? But we really do think that this is such a important area, not just analytically, but in terms of how policy actually gets made and is passed and what is able to be passed. There's just a lot of importance in this space, and so to that extent, we think that the marginal returns to additional voices in the room are still positive, and we're excited to try to contribute to that conversation. So to that end, we'll be producing the kinds of products that you see a lot in the space. So analyses of publicly available proposals, so legislation, campaign proposals, ideas in the discourse, and so forth. We'll also be working on private scores for lawmakers who reach out to us for either a quick turnaround score because they're trying to vote on something quick, or perhaps they just want additional color commentary on something and they think we have an interesting perspective. We've already began to work with a few lawmakers on that, so that's quite exciting. And then in addition, we will be just working on, I guess, what you call applied policy research and commentary on various public finance topics that are important to the sort of meta question of developing scores and what goes into a score, new metrics and so forth, the things that aren't perhaps directly tied to the news cycle. in the way that legislation and proposals are. And then on top of all of that, or rather as a sort of side effect of that, we will be posting all of our code online, to the extent possible, maximally transparent, subject to whatever data restrictions we face. And so, that's, I guess, can be thought of as either a additional product of a kind, or at least additional resource for people interested in our work. I'll skip most of this because this is there's a lot to cover, but we're led by Natasha Sarin, Danny Yegan, and Martha Gimbel, all of whom have recent experience in government, actually making and helping with policy, and who all have sort of long, both academic and policy-oriented careers in their own right, and a small but growing team of full-time staff working to build and analyze the topics underneath the hood. To this point, well, we just launched almost exactly a month ago to the date, so very new in that regard. But we've been working in, I guess, in stealth mode, you might call it, for perhaps 9 months or so now. Really focused on building up the capacity to be able to generate sort of standard, conventional, and dynamic scores you would see from a CBO, from a think tank. And so that was mostly getting the tax microsimulation model up to speed, given that taxes are sort of simplest to model in some sense, given the nature of the formulaic approach to that as a fiscal policy tool, but also there's a lot of taxes are always perennially important, and then on top of that, getting the open source FERBIS model from the Federal Reserve to work in our context to deliver macro estimates of fiscal impulses. And then, like, in the process of getting that stuff set up, we have been adding new features where either we feel like there was low-hanging fruit, or where one of us as a researcher has, like, sort of specialized experience. And so this isn't new to the space entirely, but trying to incorporate behavioral responses that go beyond what would be considered in a CBO score, which is generally limited to a somewhat narrow set of avoidance or shifting behavior, and really start to think about partial equilibrium effects of different, whether that's labor supply responses or productivity changes, or these are things that people have, of course, looked at before, but to integrate them as a sort of standard output for whatever score we analyze was a first step. We've developed some metrics of the burden that tax filing places on taxpayers. So obviously not just the budgetary or macro or distributional concerns are we also care about how simple and how straightforward it is to comply with the tax code. It's often a major goal of tax reforms, and so we want to be able to speak to that quantitatively. So built a sort of very simple but I think useful model to report tax compliance estimates as a standard output. Looking at incentive effects, I know this is something that Max Gannis, the policy engine, has been really interested in, and we've taken some inspiration there. But to be rigorous in our reporting of how tax policy changes are going to affect different measures of incentives. This is measured by different kinds of tax rates. And then lastly, we built some interactive web tools that required pre-computing a bunch of scenarios, many millions of times in some cases. So setting up our infrastructure to run using the cloud computing services that are available to us through Yale was a big part of our setup to this point. And then that sort of all got packaged into our 2 launch products, which again were really about demonstrating, hey, like, we have the capacity to do what the kind of standard analysis in this space, that we're a player in this space, and that we have the capacity to do these kinds of analyses. And so to that end, we worked on 2 documents, one for Tax Cuts and Jobs Act extension options, and another for the child tax credit. The latter with a specific eye towards some of those additional metrics we've been working on. And then, of course, like I said before, put the code that generates these analyses on our GitHub page. I'll discuss in a bit about like where, how we think about transparency and where we like currently fall short of like, genuine open source. And of course, would be interested to hear feedback in that regard, given, PSL's sort of trailblazing this space in some sense. But nonetheless, yeah, just, putting our code online, preparing for that was one of our key bits of work to this point. In terms of, what we do next after launch, we will be expanding in, I would say along two dimensions. The first is like just adding topic areas to our arsenal, and that involves building new models for topics like paid family leave, universal pre-K. Those are two that are pretty high on our to-do list. Again, to try to, build micro simulation models in some sense that are able to kind of do the same analyses, but in a different policy context relative to our tax model. And so that, that's planned for later this summer or perhaps this fall. And then in the meantime, we have a bunch of new metrics we've been developing as again, going back to the core goal of expanding the toolkit for evaluating policy analyses. We're very much interested in looking at different ways, essentially, to either cut the data that comes out of a microsimulation model or to add new modeling features or imputations that would allow us to say something more broad than is currently the case. And a good example of that is our project on longitudinal distribution analysis. The sort of standard conventional distribution table is a point in time or cross-sectional estimate. And I think for many reasons that falls short of, I think as economists would much prefer to look at something like lifetime income, recognizing that in some sense, the entire purpose of a social insurance program or a progressive or certain elements of a progressive tax code are to insure against the changes that happen over time, right? There's not just a static rich and a poor. People are poor, they become rich, they lose their jobs, they change family type, they have children, they get married, they get old, they retire. We would like to move away from the sort of static view of the population, I think engendered somewhat by point in time distribution estimates and present a richer view of how people are evolving over time in their lifetimes and how policy interacts with the fact that our lives change over time. And of course, that's difficult from a modeling perspective, given how these models work. We're projecting cross sections of the tax-paying population into the future. Right, we as researchers outside the government, we don't have access to much, if any, information on that would allow us to link tax records over time. So bringing in outside data sources to try to impute that link over time is a modeling exercise we're working on and hoping to debut soon. There's a bunch of other topics. I think I guess two others that I would highlight that I think are important. One is along similar lines to the tax compliance piece is a notion of horizontal equity analysis. There's a lot of people in the think tank world, I would say, producing very high quality metrics of the vertical distribution, right? How do taxes vary with income? How do taxes vary with wealth? That sort of thing. But with another important principle of good public finance is having a horizontally equitable code in which it's free of loopholes or sort of arbitrary distinctions between different types of people conditional on a given income. And so developing metrics to look at like the dispersion of tax rates within an income group to try to understand to what extent reforms are moving us in the direction of or away from principles surrounding horizontal equity and how those principles or how the measured understanding of those principles might vary with our normative understanding of what it means to be an equal, like a unit, right? How do you adjust for children? How do you adjust for marital status? Things of that nature. So that's another one we're excited about. And I guess the last I would highlight is this one's been tough, but we think it's important, which is in distribution tables, really trying to think through how to treat how to compare on an apples to apples basis policy reforms that increase the deficit versus policy reforms that are paid for in some sense. And that's obviously very difficult to do, again, because it relies in a very real way on predicting the future about how policies are financed, or in some cases, how what is the financing mix of a policy? Well, does an increase in the deficit today imply higher taxes in the future? Does it imply uh, lower spending on government programs? Does it imply higher inflation? Right? These all have different distribution consequences, and we want to think through and again be rigorous be able to quantify how these costs that I think most economists would agree are real in an economic sense, but are not sort of straightforward in the way that the benefits are distributed within a standard distribution table. So that's another project we're working on. Hopefully, sometime later this year, we'll have a big report on that as well. And the others I won't get into too much, but lots coming down the pike. Lots of sort of accumulated ideas from over the years working in this space, and we finally have the time and the resources to tackle some of these, which is quite exciting. So that's, in terms of like our background, that's kind of what we've been doing, I think where we're going, what our goals are. And now I want to shift gears. Yeah, we're 12:18. Okay. Shift gears for the last 10 to 15 minutes or so. I'd like to discuss, the architecture, the design of what to this point has been our core analytical tool, which is our tax microsimulation model. I'll assume that most people watching this sort of thing are familiar with the basic gist of microsimulation, but I like to describe this exercise as being a tool for scenario analysis. Is really what it is. We are simulating tax micro data under different counterfactual scenarios to learn something about how some policy change or some economic change is going to influence the budget, it's going to influence the distribution of income, influence the micro or macro economy and so forth. And so, within our broader set of micro simulation tools, we have two repositories. The first is tax data, which is focused on really just processing and projecting what are the exogenous inputs to the model itself. Again, we are using the IRS public use file as the core of our data, which, given that is a restricted file, at this point, it has made it tough for us to really expose this tool as like genuine open source. I know that in the past, some people in this space have made it such that it can run on alternative data sets. I know that Policy Engine is doing some really cool work to actually use the information from the PUF to basically model, to create synthetic data based on a different publicly available microdata set. We're very much interested in those because we believe in the value of transparency and so forth. But because we are using the PUF at this point as like the core data source, this is not something that, unless you have this available to you, you can download and run. Nonetheless, all the code is online. And so that's what tax data does. Tax simulator is, I guess, what I would describe as like the model, so to speak. It's the tool for running scenario analysis on the tax data. And within that, I think it's useful to categorize what tax simulator is doing into three buckets. One is defining what the scenario is and parsing what the user tells it to simulate. And I'll go into more detail about what the subdimensions of that are. But that's a big component, is how to communicate what the scenario you want the model to run is. Second piece is the tax calculator. Again, this is, I think there's enough models out there now that this is pretty straightforward. This is just the TurboTax style logic of implementing the policy rules. These are deterministic functions by law. There's not there's not a lot of innovation to do in this space other than to perhaps try to express the tax code in as maximally flexible functional form as possible so as to accommodate the widest array of policy reforms. But that's the second component. And so for a given scenario, we calculate taxes under that scenario for the simulated population. And then the third step is various post-processing tasks that generate the metrics we're actually interested in, whether that's revenue estimates or distribution analysis, etc. Like I said before, I want to want to dial in on the scenario configuration component here. Going back to my initial comment that these models are really tools for scenario analysis, and they, I think the main use case is to analyze counterfactual policy, like tax law reforms. But I think it's broader than that in some sense, and I think our architecture reflects that. So in our model, scenarios are defined really by three kinds of inputs. The first is the law I spoke about. So this is the rates, deductions, the rules, again expressed in try to like a maximally flexible way so as to accommodate as wide a range of reforms as possible. And of course, this is complicated just because there's so many tax parameters in the individual and payroll tax codes, all with different indexing rules, and they vary over time and so forth. So, I'll show you an example of how that's actually set up. How we as humans communicate that to the model. The second piece is the economic baseline, or what is the macroeconomic context that we're running the simulation in. To this point, this is something we haven't really produced any like public facing it's not a dimension along which we varied in any of our public scenarios, but there's nothing in principle that says we can't, for example, examine the impact of falling fertility rates on the fiscal outlook by varying the demographic assumptions that go into our tax data projections, or look at what would happen if there was another burst of unexpected inflation. What does that mean for revenues? So that sort of thing. And then the final piece is behavioral feedback, which I think is another interesting piece that we've built in architecturally, in the sense that this is distinguished from the economic baseline or the economic assumptions, in that we're really talking about deltas from baseline in response to deltas from baseline policy. So how do the attributes of the simulated population change in response to different kinds of tax changes? And in the past, when working on these kinds of models, the way I dealt with this is allowed users to specify perhaps a variable in elasticity within a range of functional forms to relate these two. But here we've taken a broader view, which is to basically provide an interface for users to submit their own custom logic governing the relationship between tax policy and between attributes that matter for taxes. So it could be something as simple as here's a function that relates marginal tax rates calculated at the individual level on capital gains to realizations based on this elasticity. But it could also be as complicated as something as we actually decided to do a more deep dive on capital gains, and we impute the stock of unrealized gains, and we want to given some parameters, we track that over time, and in response to policy changes, people perhaps realize more, the stock goes down, or they, depending on their age, they wait longer in anticipation of step-up basis of death. And I guess the point being that like it is, these behavioral feedback modules are as complicated or as sort of simple as is required for the analysis at hand, which I think is a neat feature of what we have here. Very quickly, I mean, there's not much to say in terms, I mean, this is the other thing about these kinds of models. They're, I actually think they're, they can have lots of bells and whistles, but they're quite simple at the end of the day. Like, it is just a series of data transformation tasks. So to that extent, this is written in R. I'm a bit of a tidy versus R partisan. So this is sort of natural for me, but it's very sort of functional programming design, right? It's everything's expressed as a series of functions, mapping one input to another, and it sort of takes you from the raw data all the way to the end. And yeah, supports different parallelization options, again, based on the resource we have at Yale. And I already talked about some of these data restriction issues. Um, given the time constraints, I think I'll spend about 5 minutes, if that's okay, Jason, just showing the users what the code looks like, and specifically what the tax law configuration files look like.
Yeah, that'd be great.
Fantastic. So, can you see my Chrome screen?
Yep, got it. Yeah.
Yeah. So this is the repository. Within the So I'll show the two elements of configuration that I discussed previously. The first of which is tax law. So within the configuration folder, within things that define scenarios, you'll see both tax law and behavior. Under the baseline, you'll see that we have all of these different YAML files which express the baseline tax system in a sort of specific form, where we organize these into thematic areas. Um, I'll use the AMT as an example, but within these files, you'll find all of the different elements that make up the AMT, as it were, ranging from things like the exemption to phase out rates and the brackets and so forth. And you'll see that the data structure we've designed here is somewhat flexible, um, as necessitated by the way the tax code works, in that, like, for example, like many things in the tax code are scheduled to change over time. And so you can see here, for example, the phase out threshold for married filing separately returns changes over time, is scheduled to change again in 2026. So we have the power to sort of express those in terms of a time series, then gets mapped into a sort of longer time series in the code. We also allow different specifications for the indexation rules, which are quite complicated in some ways. And in these files, they often share a lot of the same underlying rules, and so we map these back to the very top of the file, certain defaults. So in this case, this is just to say, for example, that the base value in 2026 for the single AMT exemption is $50,600. That's going to be indexed to change CPI with the base year of 2011. It's rounded to the nearest dollar, and it is in increments of $100. So that is generally what these look like when you want to specify a change. When we want to do a counterfactual scenario, the way that this works is that we only need to specify what's different from baseline. So for example, if I wanted to specify making the 2021 CTC permanent, I would just pick and choose within the CTC file what are the things that are changing, specify those, leave everything else blank, and it'll use the default from the baseline. Again, showing the flexibility of this kind of data structure we have here. It can take arrays in the case of brackets or different rate structures. It can take different data types, infinity, numerics, Boolean, and so forth. So yeah, that's what the tax law configuration files. I mean, we could go into tons of detail there, but in the interest of time, I just want to show the last piece for today, which is an example or a couple examples of our behavioral feedback modules. So going back to the dimensions of defining a scenario, if I go into behavior, you'll see that there are, again, thematic areas that organize different kinds of variables that we wish to express as functions of tax policy, so that when we run a new policy change, these variables will update in accordance of the governing logic that we specify. So as a simple example, I will use charitable contributions, given that this is a pretty simple implementation, a very reduced form approach to modeling this. So if I click on, these are different elasticity assumptions, but if I click on the one module. What you see here is this is a behavioral feedback module. That it is basically a function type interface that needs to accord with a couple of specific design choices. But other than that, you as the user are free to articulate how you want this variable, in this case, cash charitable contributions, to vary with policy as measured, again, through some, or whatever we want. So in this case, what we're doing is something very simple. Is just saying, all right, let's assume that the tax price elasticity of capital gains is 0.5. Let's say that it's uniform for all tax units. Let's just call this helper function that's going to adjust this cash charitable contributions variable with respect to the difference in the marginal tax rates on charitable contributions that we've calculated under the baseline and under the static version of the scenario. And then it updates that and returns that. And that's like a very simple example, right? There's a predefined functional form. We're just setting a uniform elasticity at the top, and that's going to generate something that would be useful, for example, in a sort of high-level budget estimate to get the magnitude of the aggregate feedback effect that people changing the amount they give in response to charity might have on the budgetary impact of a policy reform. As a more involved example, I will show you what we recently did for labor supply in response to policy changes that affect the return to work. So, this was a big debate perhaps a year or two ago in the wake of the expanded child tax credit in 2021, which eliminated the phase-in rate and thus reduced or rather increased marginal tax rates and plausibly increased or rather disincentivized working via the substitution channel. We want to measure that in some meaningful way. This case, this is it is a reform that affects, the populations of interest are quite narrow, and so we want to be more specific than what we were with this other policy reform with charity. And so in this case, what we're doing is defining heterogeneous elasticities. So, this is specifically, we're taking from a paper by Jacob Bastian that, looks at the literature and comes away with different elasticities for different groups. And so what you'll see here in this behavioral module is a much more involved function that, does several additional steps of operation so as to do something more realistic at the micro level. And so in this case, what we're doing is, defining what these elasticities by income or by demographic characteristics are at the top. We think that poor mothers are more responsive than, non-poor mothers or men making more than some threshold, right? And then we incorporate that down here by, assigning these to our tax data based on different attributes, calculating how the policy reform affected individual level incentives for work. And then, eventually, through a probabilistic simulation, if the effect was positive, if it meant that this is expected to actually increase people's return to work at the extensive margin, then actually bring non-workers into the labor force by some, probability as estimated by the change in the return to work and in the elasticity that we've specified, again, at the micro level. If instead, like in the case of the ARPA CTC, we would expect a somewhat a disincentive to work, then it does the opposite. It goes through, the earners, people who currently have, wages or earnings of some sort, figure out how likely they are to exit the labor force, again, based on their heterogeneous elasticities, based on the amount by which the policy affects them, run some simulations, and then, simulate labor force exit that way. And so, this is the point here is that, this is like quite longer, quite more involved than the other behavioral response example that I showed before. But the point is that within a given policy run, like this is here you'll see this is a run script. This is how you would actually specify to the computer which scenarios to run. you can see that there's a column for behavior, and what we're going to do there is just list off the different modules that we wanted to execute as part of the scenario. Again, trying to be flexible in this way that like we can again, hopefully using lots of different computing power available to us, vary these over time and run a bunch of different scenarios, to do perhaps sensitivity analysis, or to let people examine the impacts of what these assumptions do to the ultimate scores that we see. And so, and I guess the last thing I'd say is that I think this is of special interest to us, because I think it's clear that conditional on CBO's economic baseline, conditional on having the proper logic specified for the tax code, a lot of the disagreements within the field come down to what do we assume about these key behavioral responses? How do they impact the score? And so making that piece as flexible as possible was a key goal for us, and I think that's reflected in the design here. So with that, I think I've said enough for now. I'd be curious to hear what questions, if any, people have.
John, thanks so much for that overview, and also getting a little bit into these details with the behavioral responses. I think that flexibility is something really unique in terms of like allowing for intensive and extensive margin changes. I'm wondering though how you summarize all of these in your like total behavioral response, and if you can talk a little bit about, I guess, how you summarize them as a whole, and then how you might use this to update the economic baseline for reform.
Yeah, when you say summarize, you mean I guess what exactly?
So, I guess, often when we're looking at like a budgetary effect, right, we're thinking about a reduction in earnings by individuals as a behavioral response that's going to lower, their pre-tax income, which will lower the base, which lowers the revenue. But you have these extensive margin changes happening. So do you like how is that feeding back into the budgetary effects that
Right.
you're
Yeah.
having?
So the way that the order of operations in the execution here is that like when you specify one of these behavioral feedback modules, first under a counterfactual non-baseline scenario, first the simulator is going to execute the purely static version of the policy, both to just get the first order effects in measured, but also to measure whatever to measure the I guess the to in some sense characterize how tax policy affects people at the micro level. So for example, calculating different kinds of marginal or average or extensive tax rates that are then fed into the behavioral feedback modules. So then we run the static version, then we say, okay, here's the static, here's all the information we need. Now execute these behavioral feedback modules specifically in the order that you tell it to. And so there's like stacking questions there, right? So then at which point then it adjusts the attributes of our tax population, and then recalculates taxes, and then sort of from that is going to naturally flow out into the simulated microdata, and thus the whatever aggregation we do in the post-processing phase.
No, that's helpful. I was just thinking about the fact that your records are some kind of weighted sample. So, having a record go from like working to not working is a big change. But that's where you're doing that simulation of there's a probability you return or not. So some fraction of a representative record, if you will exit or not.
Yeah, exactly. And I think what I hear in that follow up is like, so much of how this work is done is through adjusting the weights to be representative in the aggregate level of some, consistent with some targets we have, and it's usually so as to preserve the joint distributions. We normally don't touch we're not zeroing people's wages out when we say that, oh, like employment's projected to be slightly lower next year according to CBO's baseline or something, right? We're gonna operate that on the weights. And so yeah, this is in the case of like we're certainly not doing anything like this in the baseline. It's done in a similar way with like weights are the key mechanism along which something like total employment would be targeted. But in the case of behavioral feedback, we allow changes to the values of specific records.
Yeah, great. Other questions from the audience? All right,
John,
well, I've got it. Oh, yeah, please go ahead, Matt.
This is Matt. When you're thinking about some of the labor supply effects, I guess the total tax wedge matters a lot. So if you're talking about going from like, you know, a 80% marginal tax rate to a 60% marginal tax rate, that's like 100% change in after tax pay. And then if you're going from a 20 to a 0%, it's like a 25% change in after tax pay rate.
Yeah.
And so then things like the marginal tax rates from all these like state and local taxes and then benefit programs, they could potentially matter quite a lot. So I'm just wondering how you've kind of like thought about getting the tax wedge right when we're thinking about federal tax policy reform with a federal microsimulation model. But then like, kind of we need to what ideally, I don't think many people have, but ideally you'd be like kind of taking into account the total tax wedge from all the other benefit and state and local tax programs, if you have any thoughts on that.
Yeah, no, I mean it's a great point, and it's something I've talked to Max Guinness about. He's in part I think a big reason why you do need the full spectrum of all of these different programs, even down to the silliest or smallest like housing subsidy or whatever, because these things do matter for measuring incentives. I think the cop-out answer is that like trying to find a functional form that expresses these in like percentage point changes to kind of control for that intercept is probably, I think, one approach. I think the other is probably estimating perhaps an average from something like Max's tool or something, and then imputing that, and then sort of using that as the base off of which we calculate a relative change metric, because yeah, otherwise it is. I mean, it is a good point. And quite frankly, like building out 50 state models and all these benefit programs is something where it's not, we don't have the resources for the time to do, and that's already done by someone like Max. And so, yeah, probably leveraging someone else's work in that space is probably very important.
Okay.
John, could you talk? I know we're getting close to time here, but I'd like to hear a little bit more about the like longitudinal distributional analysis, and I guess that works kind of hand in hand with, or at least that would be something necessary to think about kind of distributing the debt, because that's taxes now, or tax cuts now that are debt financed, or future taxes. Just if you could, just a high level overview. Are you thinking about like a life cycle model, or do we think about there's just an exogenous process through which households kind of march through time in terms of their earnings and savings and so on?
Yeah, it's definitely the latter, in the sense that it will be, again, if I should say, if we can pull this off. This is something I've been interested in, but of course it is very, very difficult, and we have results, but there's still much to be done here. But yeah, it's going to be something more reduced form. I think in part because that's I think more tractable for this kind of work. Also, like I don't know that we're thinking of looking so far into the future, that I do think like if we're looking at like a 5-year panel, something like that, or maybe even like the budget window or something, then we can probably get away with that. But yeah, it's going to be based on estimating transition functions between the different attributes that we think are important for accurately calculating the effective taxes over time, right, namely demographic, core demographic attributes, and income and its components. And even that latter piece is difficult. It's probably going to be something as high level as wages, non-wages. And what that's actually going to do is limit us to probably only use this for reforms that do not, involve changes or tweaks around the margins to, I don't know, like very special kinds of tax provisions. It's much more suited, I think, to do something like, and this, this is actually kind of the initial impetus, but something like a child tax credit reform, where it's a pretty straightforward function of your demographic attributes and your income, and your earnings specifically. And so there having a model of these, like, a handful of characteristics would probably get you most of the way. What we would not be able to do is like do distribution or panel this analysis for, say, the full TCJ, because there's just too many moving parts there, and that we don't, we would essentially be overstating the amount of people who we would be overstating the volatility and the reform's impact on tax burden, given that, like, QBI deduction will get washed into all of these things, and you'd be transitioned in and out of it too frequently.
Yeah. Well, that is ambitious, and like many of the things you're doing, and you have a great team you're working with. So I know you'll get it done, but it's just something I think is going to add a lot of value. Thinking about the panel dimension here, thinking about things that other budgetary shops are not looking at, like some of the compliance costs and distributing the debt. These are all super important, and we're excited Yale Budget Lab is thinking about these, and that you're a part of that, John. So thanks so much for sharing with us. Hopefully we'll have you back and you can do a demo so we can get our hands on the tax simulator or other models you all are working with.
Absolutely. Would love to come back and discuss some of these projects. Thanks, Jason.
John, thanks so much. Have a great day.
All righty. Take care.
Bye.